Alright, today I'm going to be making a video tutorial of how to make a good looking sine wave in Excel. So we'll start with our t table of our x and y values. And for a sine wave, it's always going to be time. You can put t here, you can put time, doesn't matter. And our y values, you can call this the wave itself. Here I'm just going to call it y. So I feel like the trouble that most people have been having is what increments to use, what values to put in these in the time column here. And so a lot of people, I think, are just making up values. They're saying maybe 0, maybe 0.1, and then it'll go 0.2, I guess. But these values are actually really important to think about and make purposeful decisions in order for your time wave to come out well. So let's start, and I'm just going to expand this and say that this is going to be the sine wave that I want to graph. I will have an amplitude of 5 sine, and then it's going to be 2 pi, okay, it's always in there. And then we're going to have a frequency, let's say a frequency of 1000, okay? Then our time values. And for the sake of this tutorial, we're just going to leave off a phase and a DC shift. So if this is what I want to graph, then I need to enter this formula in the way that Excel wants it into my Y column. So I always start with an equal sign. I have the amplitude, and then anytime there's multiplication involved, which is pretty much all of these things, I need this asterisk here. So I have 5 sine, and then the parentheses to start the argument. I always have 2 pi, so I need to have 2 times this pi symbol times my frequency, which is 1000 in this case, and then times the time value. And then I close that argument. So now I can start entering some time values here, but I can use what I know about the waveform in order to pick good values to plug in that'll make sure that this shows up in a graph. So if I just put in 0.1 second, 0.2 seconds, 0.3, and let's say I take this to 1 second, like I've seen most people do, and I drag this formula as well. If I look at these values before I even graph it, I know this is not going to show me anything. These values, e to the negative 12, e to the negative 14, are basically 0. But let me just show you what it looks like. Okay, this is not the sine wave. All of these values are pretty much 0, just hovering around 0. This is a bad sine wave, and it's not because you plugged in the formula wrong. This formula is correct. It's because you chose poor time intervals, okay? And let me show you why. And this is why the period is important. So let me just calculate the period here. The period of a 1000 hertz sine wave is equal to 1 over the frequency. So 1 over 1000. That means that this sine wave does one full cycle in 0.001 seconds. Okay? That means in this first interval, you've already plotted 100 sine waves, 100 sine waves within this one interval between 0 and 0.1, and you've landed right on 0 again. Okay? So this is why these intervals are not appropriate to plot a 1000 hertz sine wave. What I like to do is calculate the period for whatever frequency my sine wave is, and I know that my time values are going to go from 0 to whatever this period is, and that means I'm going to be plotting one full cycle. Okay? So it's going to go from 0 to 0.001 seconds, but now I need to decide what goes in the middle here. Okay? So I'm not going to use these values anymore. Just like that. I know these values are going to go from 1, and then there's going to be some number of increments in here, and they're going to end at 0.001. Okay? So how do you decide what increments to use? Well, we know they have to be smaller than this. Okay, so these are going to be some very, very tiny increments. What I like to do to decide what increments or intervals I'm going to use is take the period and divide this period by 1,000. So I'm going to take this or divide it by 100. It's going to give me an even smaller number. I'm going to use this as my increment for my time values. So it'll go from 0. The next one is going to be 0.00001, which means the next increment is going to be 0.00002, right? It's going to keep going, 0.00003. And instead of typing all these, remember I can highlight all of them. This shows Excel what my pattern is, okay? If you just highlight one of these and say, I want this to be copied, you've only given Excel this one box as your pattern. So Excel just thinks that you want this repeated over and over and over again. That's not what we want, right? We want to repeat this pattern. So you have to give Excel the pattern. So let's give it this whole pattern. We know now, Excel knows that, oh, you just want to add 0.00001 in each row. And remember, right here in this box below my plus sign, it tells me what the number is to that point. And remember, I need to go all the way from 0 to this period, okay, in order to graph a full sine wave. If I didn't go all the way to this number, all the way down here, if I just stopped here and plotted this many points, I'm going to get rid of this because it's not going to know what to do. If I just plot this many points and make a chart, I've only started to plot a sine wave. This is not one full cycle, right? This is just going up. It still needs to come back down, go negative, come back to 0 again. Okay, so I haven't shown a full sine wave with only this many points. Okay? I need to keep going all the way to my period. And since I've divided it by 100 to get here, I know that I need to go all the way down to about row 100. Since I have a label at the top of my column, it goes to 102. And there you go, 0.001. So I know that this is going to graph one whole period. I need to drag these values down too. Oop, man, this little mouse goes fast. And now look at my sine wave when I plot it. Insert, scatter plot. Remember, don't use curved lines. You're going to be using straight lines. And voila, this is a 1,000 hertz sine wave, which has a period of 0.001. And I guess for good measure, I will make a sine wave. Let's do a sine wave. Let's call it y2. This will be y1. Oops, y1. This will be y2. I'm going to do the same sine wave. Oops, dang it. Let's not do that. I need to readjust. There we go. Let me just retype it. I have an amplitude of 5 times sine 2 times pi times 1,000 hertz times, let's t plus, let's change this, let's add a phase shift of just pi. So we don't actually need to put a parentheses unless we're doing pi over 2 or pi over some value. But we need to close the sine argument. We can copy this all the way down. Since it has the same frequency as our first sine wave, we don't need to worry about the increments. And let's plot these two sine waves on top of each other and see what they look like. Ta-da! Here's y1, a regular 1,000 hertz sine wave, and here's y2 with a phase shift of pi, which just flips it 180 degrees, just flips it upside down. So that's how you would plot something with a phase shift. we can change the frequency. Let's plot another one, but this time let's have an amplitude of 3. So this is going to be a smaller sine wave. 2 times pi times, let's do 500 hertz. So this is half of the frequency of our 1000 hertz sine wave times t. Close the argument. Copy this formula. Geez, this goes so fast. Okay. Let's plot all 3 of these time waves on top of each other. Insert a scatter plot. Here is a 500 hertz sine wave, but you can see that we're only looking at the positive half of the sine wave. This keeps going down here and up back to 0. The problem is I just didn't have increments that went far enough. I have intervals that are good. I'm seeing really good, very smooth line. I just don't go far enough in order to plot one whole period. So let's try that. Let's go all the way to the period of 500 hertz. So this is the period for a 1000 hertz sine wave. This will be the period of a 500 hertz sine wave, which is equal to 1 divided by 500 hertz. 0.002 is the period of a 500 hertz sine wave. So let's keep going to 0.002, which should be somewhere around 200. 002. And it's going to didn't automatically update it. Let me just plot a new one. Ta-da! The blue line is our 1000 hertz sine wave, and this time we've shown 2 periods, so 2 cycles of it. The orange is a 1000 hertz sine wave with a phase shift of pi, or 180 degrees. Again, it's showing 2 full cycles because we've gone times of the period times 2 of 1000 hertz. And this gray line is the 500 hertz sine wave, and we've only gone out to 1 period, so it's only showing 1 cycle of this 500 hertz sine wave. So this is how you make a good looking sine wave in Excel. So I hope that this helps. Please email me if there are any problems with this video, or if you still need clarification for how to do this in Excel. Hope you have a good weekend.